Okay, let's start. Good evening, everyone. Assalamu alaikum warahmatullahi wabarakatuh. Today is our lecture number 4 or session number 4 in the introduction in oil and gas industry. So today, inshallah, we'll speak about the reservoir and wells. We'll speak about the reservoir and wellheads. So our agenda today, we will have some point to discuss first. We'll explain more about exploration and drilling. So we'll go more in details about the drilling and exploration. Then we'll speak about the well. We'll speak about the well casing and the completion. What is the difference between well casing and the completion? So if you remember, this sector is which sector now? We are upstream or downstream or midstream? Yeah, I know you are muted your mic, but I understand that you all of know that we are in the upstream section, correct? This is the upstream section where we are now. So this is the upstream section. Here, this all what we are going to speak today, the drilling, the exploration is related to the upstream sector. So drilling exploration is related to the upstream sector. So let's have some more definition about the exploration and drilling in the upstream sector. Actually, the whole life cycle in the drilling, it is consists of 2 or 3 stages mainly. First stage is the drilling itself. Second stage is the completion, which should become after drilling. So the drilling will come first to drill the well. After the well is well prepared, then they need to do some other arrangement is called completion. We'll explain this. After then, they will start to have production or to produce the oil or gas. So the first is drilling, second completion, third production. The drilling, first drilling rig. Drilling rig is the main item in the drilling cycle. This drilling rig, when it will come, after the people, they do the 3D seismic investigation. So as we told in the last lecture, how they know there is an oil or gas in this area, they are doing 3D seismic investigation to explore the possibility of having any oil or gas in this area or this land or on the sea. So they do 3D seismic investigation. So it is like a signals that is going to the ground, to the layers of the land in the ground. So when it have some reflection, then they recorded on their system, computer system, the waves that is reflected. They transfer the 3D waves into reading, and they understand these layers is consist of oil or gas or water, and what is the composition. So after they done this first, then they know there is an area or there is a potential fluid or flow of oil or gas in this area. Then they start the drilling. So the main component of the drilling rig, as you see in the photo, this consists of the top driver, the derrick, and the rig floor. The derrick and the top driver and the rig floor. Let's have more explanation about this drilling rig. This is the derrick. This is structure is called derrick. This is the top drive, and all of this component is related to the wellhead and the drilling area. So the main item, as I told, is the derrick. There is some other items related to the drill pipe itself, the pipe deck, which has located all the pipe on the pipe deck. There is drill floor. There is also another area for the power system and for the top driver and for the crane. But this is mainly how the drilling rig is consist of. Another photo is give you focus on the system, not component, system of the drilling equipment. We have the power system. This power system is required to supply the drill rig with sufficient power, electrical power. It's not only the drilling rig, it is also the pump that is required to have circulation, which will come in this second system, which is the circulation system. This circulation system will consist of pumps, and these pumps will circulate fluid calling mud. Mud will explain this. This mud is very important for the drilling. We have a rotating system. This rotating system is mainly for the drilling pipe or the drill stem, the pipe itself that will penetrate the ground or the land. It needs to be rotated, it needs to be operated, it has to have a rotation system. And there is very important system called the blowout prevention system. Blowout prevention system. This is mainly for control the fluid that's coming out of the well. To control the fluid, the pressure of the fluid, which will come with very high pressure, severe pressure, you need to control it with a prevention system to avoid any explosion in the system. When it comes suddenly, you are drilling with the machine, the fluid will come suddenly, immediately, because it has very high pressure. You imagine the layers of the land, of the earth, and this fluid, this oil or gas, it is located in maybe 1,000 meter or 2,000 meter underneath the level of the earth or the level of the land. So it is very deep, and this actually depth has a lot of high pressure because of the layers of the land, of the earth, of the ground, a lot of high pressure, a lot of high temperature. Imagine that you are start drilling, so you give a breath to this high pressure to suddenly pump up. Imagine that's high pressure, something in high pressure underneath the earth and the land, and you are drilling, you give them opportunity or a chance to pop up because you give them a way or a hole to the atmospheric pressure. So the differential pressure between the pressure which is in the depths of the earth under the layers of the earth, maybe 1 kilometer underneath the top of the grade level, to the other difference between the atmospheric pressure. Immediately the high pressure, the flow will go from high pressure to the lower pressure. So this will have a lot of flow comes immediately. How you prevent, control this flow? You need to have a blowout prevention system. You need to have what? A blowout prevention system. This is very, very important for the safety, for the controlling system, for the hazards, for everything. This is very important. So this is the main systems of the drilling rig. And as I told, this is again the main component of the drilling rig. We have a derrick, the structure, the hoisting system, which is all other elements related to the structure itself. We have the rotating system, we have circulation system, we have power system, and we have blowout prevention system. As I told, it is merely for controlling the high pressure fluid which is flowing up out of the land from the well, mainly. So this is the first item, which is the derrick. This is the derrick, and this is how it looks, either on the land or on the sea, on the ship. This is the derrick, and this is the main structure. You need to remember the photo. This is the hoisting system. The hoisting system is all the cables, the lines, the wiring, the block, the traveling block, the anchor, the fast line, the drum brake, the storage reel. This is all the mechanism to operate the well, and accordingly it will go through the what? The drilling pipe. This drilling pipe, how it go ups and down through all of this wiring and all of this system is called hoisting system. Hoisting system. The rotating system is a system that's actually mainly for rotationally, for rotating the pipe itself, the drill pipe. So the drill pipe is required to be rotated. So who can operate it? It's being operated from the rotating system. It's required from Cyril, the Kelly, pushing rotary table. This rotary table is to carry all other rotary items. Then it will also carry the drill pipe and the drill collars and the bit. These all items called the rotating system. The rotating system. The circulation system, this system is required for the mud circulation. What is the mud? The mud is a fluid which is required for penetration, required for the drill. When you are, for example, you have a car and your car has a piston and has what? Has a shaft, right? So the shaft or the thing that is rotating inside the piston, it has some friction and has some penetration, is going ups and down. This is the motor of the car. So how you ensure there is no friction, there is no heat comes out from the friction between the metals itself, you insert oil, which is car oil. This is car oil required for lubrication, for removing the particles, the elements, to removing everything to make the movement cycle smoothly without any problem, without any friction, without high temperature. So the things will go smoothly. The things will go smoothly. This is a short example, and this is the same for drilling. You have a drill rig, you have a hole, you need to ensure a smooth penetration. So how you ensure a smooth penetration using a drill rig, a drill pipe, and a well? By using a fluid called mud. Mud. And this mud has mud house, as you see here. This is mud house, including the mud. And as I told, this mud is a fluid, is a liquid, but it is viscous liquid, very high viscosity, to ensure that it will carry all the particles and the solids comes out of the drill, and it will be removed out from the well. So that's why it requires pump to circulate, or pumping this mud fluid to the circulation system, to the well, to the drill pipe here. So this mud pump will pumping the fluid through the standpipe to the rotary hose to the drill rig. And this is the drill rig, start from the civil and Kelly and the drill pipe and annulus. This annulus, this is the location or the portion that will be on the well. So the mud will go there until the pit, which will here giving the benefit of removing any particles and removing any high temperature and doing the lubricate, doing the smooth penetration, doing the smooth drilling for whole drilling system. So this is mud, as I told, this is very important for lubrication for drilling. The excess or the extra mud that will come out of the system will go through the mud pit and then go to reservoir pit. This is for other recirculation. To recirculate again the mud, removing the circular pit and or removing the mud at all if it is become useless. They can remove it from here. Or they can make a chemical treatment to the mud. They can make a chemical treatment using a chemical tank and circulating again to the pump, to the mud pump. Okay, I hope this is clear because the mud is very important in the drilling system or in the drilling industry. There is some people called the mud engineer. He is mud engineer. His position is mud engineer. So he's working as looking for the mud and specification of the mud, specification of the pump related to the mud. This is the mud pump. This is how it looks. This is also another photo of the mud pump. This is another type of the mud. These are kind of single acting design like this. This is the same design or the same configuration of the motor, car motor. The car motor, we have piston rod and we have cylinder, and this is the same as the mud single acting type, the same design. Or they can have double acting design, It has here suction and discharge. Suction means that they are sucking the fluid, which is mud, and discharging the fluid from the other side. Suck and discharge. This is the pump, actually, how it works. The same in our body, we have a heart. This heart is working as a pump to pump the blood into our body, to suck and discharge. This is the pump in our body. It's called heart. Our heart is working as a pumping system. But in the industry, we have pumps similar to it, and this is suction and this is charge, but the fluid here is different. Definitely, you have mud. Okay. Before they start the drilling, they have everything ready. They have to prepare the site for the drilling. Preparing here means that they need to do leveling of the site. They need to do grading of the site. They need to ensure that the land is all equal without any ups and downs. They have to level it. So nothing in the earth is unique or ideal. You need to prepare it. So before you start to do a drilling, you need to prepare for drilling. Preparing, as I told, to make a level of the land, make it everything clear, so that you will avoid any problem or any imbalance in the structure during the drilling. You know, this is very high motorized machine, vibrated machine, very heavy, huge. The weight is thousands of tons. So you need to ensure the land is, the surface of the level is equal, is the same. There is no any possibility of different levels that will cause a lot of vibration or a lot of problems during operation, correct? If you have, for example, a machine in your house, okay, this machine, for example, is a washing machine for your clothes, to wash your clothes. Before you put the washing machine on your kitchen or on your home or in your bathroom, what you will do first? You will make sure that the level of the ground is equal. There is no slope, there is no issue in the ground because it is motorized, it will be vibrated. You have to ensure it is balanced, it is standing on the same level. This is the same here. They have to do that. As you see in the photos, they have to do the leveling first of the ground before they put the huge machine, which is the drilling rig. All right. Then, what they will do next? They will put the drill string. And the drill string, actually, this is assembled from pipe segment. Is about pipe segment, is about 30 meters length of pipe segment. This is actually has different shape, either with conical side threaded at the end and outside at the other. So this actually each one of the first 30 is drilling, is to drill, and the driver actually is disconnected, and a new pipe segment is inserted into the string, and this is the connection to the pipe string. Actually, it is the last connection to connect the pipe drill. You connect with this drill string. And the well actually can be in any depth. The well, it can be any depth. It can be more than 6 kilometer. It can be less than that because the oil normally is formed at the level of 3 kilometer to 4 kilometer. So the well depth is variance from 3 kilometer to 6 kilometer. So it depends on that. You need to design your well, your pipe drill to know exactly what is the required length to penetrate according to this. And actually, the pressure, as I told, and temperature generally increase with increasing the depth. When you go deeper, the pressure and temperature will increase dramatically or accordingly. When you go up, the pressure and temperature will decrease. This is normal until you reach to the surface. So again, if you go deeper and deeper and deeper and deeper, the pressure and temperature will go higher and higher and higher and higher. That's why, as I told, you need to have blowout prevention system. If you go deeper, 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 until you reach to depth of 6 kilometer, imagine the high pressure that you will find. If you start to drill, a lot of flow will immediately blow out. So how you prevent that? How you prevent the sudden shock? Yes, we need to use POP or blowout prevention or blowout preventer, blowout prevention system. So as I told, people use the mud, and this mud, this is the fluid, and this is the mud which enters the drill pipe. This mud enters the drill pipe through the circulation system that we have explained. This mud serves many purposes. First, it brings rock shells up to the surface, so you have a rocks. So these rocks will be out of the surface. Second, it cleans and cools the cone. As I told, you have high temperature. You need to ensure this high temperature will be cooled a little bit. So it ensures that you are cooling the cone. The cone, which is the drill string, this is at the last stage of the drill pipe to penetrate with it. You need to cool it so it will not cause any fire or anything. Cooling using the mud, and also to clean it. So as I told, it is also for smoothing and lubrication. It lubricates the drill pipe string and cone. So you need also to lubricate, make it smoothly drilling. You need to have a lubrication system using the mud. As you are using the oil in the car for lubrication, you are using here the mud also for lubrication. The other also usage of the mud is to have fibrous particles attached to the well surface to blind solids. Also, the mud weight itself should balance the downhole pressure to avoid any leakage of the gas and oil. So imagine that also the mud is working as a seal to avoid any leakage. Sealing, you know what the meaning by seal? Sealing is something that you are closing any leakage from any area, from any surface. Sealed by like you are closing the things, sealing it, closing firmly. So the mud itself, the fluid, is working as a seal. With its pressure is equalize the other pressure of the oil and gas, which will prevent the oil and gas from sealing or from leakage, from leakage. So, as I told, to prevent the uncontrolled blowout, you need to use a blowout prevention system. So you have subsurface safety valve is used, and this is work as the safety valve to prevent any blowout coming, which is uncontrolled. You have a safety valve to control this kind of sudden flow that comes immediately without any control. So you have safety valve, it has a set pressure installed design with a set pressure. When the pressure it comes out of the design pressure of the safety valve, it will automatically close the system. It will and can withstand with this very high pressure and immediately will close the system. This is another photos of the mud pumps with the mud pits and with the mud tank. So it is very important, as I told, for the drilling and circulation system. Let's have some video to see more explanation about the drilling from this video.
After the well site has been carefully prepared to meet environmental, health, and safety standards, drilling can begin. This is an intricate operation requiring a well-planned infrastructure. A variety of processes and expert, well-trained specialists are used to bring natural gas to the surface. Chesapeake works with these experts during every aspect of the project, while strictly adhering to all individual state regulations. During the drilling process, the rig is in constant operation 24 hours a day, 7 days a week, for approximately 21 to 28 days. As an added precaution in some areas, a protective mat covers 2/3 of the pad site. Utilizing heavy-duty industrial-strength drill bits, a typical well is drilled in several stages, starting with a large diameter drill bit and then successively smaller drill bits as the drilling is advanced. After drilling each portion of the well, nested steel protective casing is cemented into place. This will protect groundwater and maintain the integrity of the well. Initially, and prior to moving in the drilling rig, a large diameter hole is drilled for the first 50 to 80 feet. Conductor casing is then cemented into place, stabilizing the ground around the drilling rig and wellhead, and isolating the well from most private water wells. In the Marcellus area, the freshwater zone extends to approximately 800 feet below ground. The freshwater zone consists of porous sandstone and rock stratas containing water within the pore space of the rock. Chesapeake utilizes air drilling until the hole is advanced to an average of 100 to 200 feet below the base of the freshwater zone. This provides added protection to the freshwater zone. A series of compressors and boosters generate the air that is used to lift the rock cuttings and fresh water into steel bins. The rock cuttings are then disposed of within state guidelines and permits. The drilling equipment is retracted to the surface and stored for the second stage of drilling. To protect the integrity of the hole and to protect the surrounding deep freshwater zone, a second layer of steel casing, called surface casing, is installed and cemented inside the newly drilled hole and conductor casing. Cement is pumped down through the surface casing and up along the sides of the well to provide a proper seal. This completely isolates the well from the deepest of private or municipal water wells. A blowout preventer is installed after the surface casing has been cemented. The blowout preventer is a series of high-pressure safety valves and seals attached to the top of the casing to control well pressure and prevent surface releases. Next, a small drilling assembly is passed down through the surface casing. At the bottom of the casing, the bit drills through the float equipment and cement, continuing its journey to the natural gas target area as deep as 8,000 feet below the surface. The drilling method employed below the surface casing uses drilling mud, which is a non-hazardous mixture based on bentonite clay or synthetic thickeners. In addition to lifting the rock cuttings out of the hole, drilling mud also helps to stabilize the hole, cool the drill bit, and control downhole pressure. A few hundred feet above the target shale, the drilling assembly comes to a stop. The entire string is retracted to the surface to adjust the drilling assembly and install a special drilling tool. This tool allows Chesapeake to gradually turn the drill bit until a horizontal plane is reached. The remainder of the well is drilled in this horizontal plane while in contact with the gas-producing shale. Drilling continues horizontally through the shale at lengths greater than 4,000 feet from the point where it entered the formation. Once drilling is completed, the equipment is retracted to the surface. Then, a smaller diameter casing, called production casing, is installed throughout the total length of the well. The production casing is cemented and secured in place by pumping cement down through the end of the casing. Depending on regional geologic conditions, the cement is pumped around the outside casing wall to approximately 2,500 feet above the producing shale formation or to the surface. The cement creates a seal to ensure that formation fluids can only be produced via the production casing. After each layer of casing is installed, the well is pressure tested to ensure its integrity for continued drilling. A cross-section of the well below surface reveals several protective layers: cement, conductor casing, cement, surface casing, drilling mud, production casing, and then production tubing through which the produced gas and water will flow. 7 layers of protection. Horizontal drilling offers many advantages when compared to vertical drilling. Since horizontal wells contact more of the gas-producing shale, fewer wells are needed to optimally develop a gas field. Multiple wells can be drilled from the same pad sites. For example, development of a 1,280-acre tract of land using conventional vertical drilling techniques could require as many as 32 vertical wells, with each having its own pad site. However, one multi-well pad site with horizontal wells can effectively recover the same natural gas reserves from the 1,280-acre tract of land while reducing the overall surface disturbance by 90%.
Okay, let's continue, dear brothers and sisters. So, after this video, it is explain you the cycles of the drilling, start from the drill string through the drill casing and all the other way to the wells, and describe the difference between vertical well or vertical drilling and horizontal drilling as well. So let's speak about the well itself. So once the well is drilled, it must be completed. So the completion is a step other than the drilling. It's called completion, which start from the casing and then completion. So completion of the well consists of a number of steps, such as well casing, well completion, installation of the wellhead, and installation of the lifting equipment or treated formation as required. So the drilling itself is a sector or is a portion or a stage. Then the completion is another stage, which will start with the well casing. So the well casing is part of well completion. Well completion. So this well casing, what's meaning by well casing? Actually, you need to have a protector around the well itself, around the pipe. This protector is a casing. So installing a well cases is very important actually during completion, because this is considered a protection to the tubes which is being inside the well. to protect it from any damage. You have to protect it. So you have to put a casing. It's considered from cement or from any other material to protect the pipe or well pipe. So let's go through more details. We have many type of well casing or many layers. We have a production casing, we have intermediate casing, we have a surface casing, we have a cement casing, we have a conductor casing. Here another photo of the casing. You have here a surface casing. Intermediate casing is the longest one, and the more longer one is the production casing. This is all layer of casings for protection of the drilling itself, for the drill pipe, to being protected from damage or from any corruption. For example, the conductor casing. This is the conductor casing. Actually, the conductor casing is very small, is around maybe 7 to 17-meter length only. So it is installed first as a conductor casing. It's installed before any other casing, and it is a larger one, larger in diameter. This is to avoid the well from caving actually, and to avoid the well from caving. So this is a larger diameter and the shorter inlets. This is the conductor casing. Then you have the surface casing. Surface casing is the next layer of the casing to another protection. This is will reach up to 400 meter, so it is more longer than the conductor casing. However, the diameter is smaller, so it can't be fit inside the conductor casing. It will be fit inside the conductor. So what is the purpose of this surface casing? It serves as a conduit for drilling mud. It serves as a conduit for the drilling mud itself, returning to the surface. So this returning mud is this drilling mud is going down and returning again. So how he can return? There should be a conduit or path for returning. This conduit or path, this is the surface casing, will serve as a conduit for the returning mud to return back again to the surface. And it helps also to, as I told, as a protection to protect the drill hole from the damage during the drilling. The other casing is called the intermediate casing. The intermediate casing is more lengthy than the conduit and the surface casing, but it is more shorter or more smaller in the diameter, is more smaller in the diameter. Then you have a production casing. This is the production casing is actually called the oil string. This is the longest string, and this is the longest casing, which is installed last, the last one. And this is the smaller one in the diameter, the production casing. This one, this casing is to provide the conduit actually from the surface of the well to the production or the petrol formation. This is called the production. So they have the production itself, the hydrocarbon and the oil and the petroleum. So as I told, the size of this production depends on a number of considerations, maybe including lifting equipment that used, or number of completion required, or possibility of deepening the well in a later stage, so and so on. So it is also they have in this one is also an instrument they call it blowout prevention, as I call, to prevent the blowout, the shock blowout, and prevent the system, and it's called for safety. This also will be on the top of this production casing. Then the well casing, that's the casing that you have the tube. You have the tubing at the end. That tubing, this tubing will use for drilling itself. This is the well, the tube casing or the well casing itself. This is the tubing. The last thing after the tube will be inserted inside the annulus, and this will be inside the production casing. This tube will have the pipe to start the drilling. This will be small in diameter, and as I told, it will be inserted inside the production casing. Okay. They use something called a backer. This backer is used to prevent any oil from a back pressure flow. When the oil or in something is returning back, you have to seal it. You have to ensure there is no return back flow coming up to the surface. You use backer as a seal or closing the things instead of going ups and down without any control. You have to control it using a backer. This is well casing, and this is well. This is actually before you completion. This is the drilling, and this is after completion. This is after completion. You start to put the wellhead and the drilling and the casing here inside the system. Here you're just preparing the drilling for production. Let's have another video to understand more about the casing and well casing.
Student, I write long essays.
So I will share again.
That I'd work on for days, but now I'm writing.
In this video, he will explain about the well casing. That's what I explained, but he will explain with more photos and animation so you will understand clearly the type of casing. As I told, there is many type of casing. There is production casing, the intermediate casing, the surface casing. So let's see this video and see.
Virtually every well drilled requires casing and cement. Casing is steel pipe that the Franks International crew puts into the well bore. The casing prevents the hole from caving in and seals off formations. To do its job, though, the casing has to be cemented in place. A cement crew pumps cement down inside the casing and up the annulus. The cement hardens, or sets, to hold the casing in place. Casing is steel pipe that comes to the rig in individual joints. A Franks casing crew couples the joints together to run them into the well bore. The length of individual joints used depends on the well owner's requirement and the physical requirements of the well. Casing also comes in different grades or strengths. Which strength is used depends on the well's construction. To run the casing, the Franks crew joins the joints of casing with threaded connections. We make up the casing joints with multi-speed power tongs. Power tongs not only screw the threaded connections together, but also apply the correct amount of torque. We use special heavy-duty elevators and large casing slips called spiders. By the time the crew drills the well to final depth, it usually has several strings of casing in it. These strings are called conductor casing, surface casing, intermediate casing, and production casing. Notice that the cased well looks something like a telescope pulled out to full length. As the drilling contractor drills the well deeper, the size of the hole and the size of the casing gets smaller in diameter. Almost always, the drilling contractor cannot begin drilling at the surface and go all the way to total depth in one step. For one thing, formations near the surface tend to crumble and cave in easily. So, conductor casing prevents cave-ins. Surface casing provides foundation for the wellbore structure. Just like building a house, a good foundation is the beginning of a solid structure. For another thing, deep formations are sometimes called troublesome formations. That is, they can be drilled by adjusting the properties of the drilling mud, but once drilled, they need to be sealed off to prevent problems with drilling the deeper portions of the well. So intermediate casing seals off troublesome zones. Sometimes deep wells require more than one intermediate casing string. Finally, once the producing zone is drilled, it needs to be protected and sealed, so production casing isolates the producing zones. The first string of casing is the conductor casing. The hole jetted for it is pretty big, often as much as 36 inches or more. The conductor hole has to start out pretty big because as drilling goes on, the hole's diameter decreases. Using a bit, whose diameter is small enough to easily go inside the conductor casing, the rig drills the hole below the conductor to a prescribed depth. The diameter of the surface hole can still be relatively large, say 22 inches or more. The surface hole's depth is set by regulatory agencies. This depth could be from hundreds to thousands of feet. Normally, the BOPs connect to the surface casing at the wellhead, so this casing must be strong enough to support the BOP stack.
This is the BOP. BOP is a blowout preventer or blowout prevention. This is a blowout prevention system to avoid any blowout that comes out from the well, which is uncontrolled pressure, high pressure. You need to uncontrol it using the blowout preventer. This is a blowout preventer. This is a machine. It will be installed on the top of the wellhead here, as shown in the video.
In addition, it has to withstand the gas and the fluid pressures that the well may encounter. Surface casing also has to be strong enough to support the additional casing strings hung inside of it. To drill the intermediate hole, the operator chooses a still smaller in diameter bit, which easily fits inside the surface casing. A bit of about 18 inches in diameter is one example of the size. Intermediate casing is also cemented into place to seal off troublesome formations, like lost circulation zones or abnormally pressured zones. It is often the longest section of casing in the well. Therefore, it anchors the BOPs for the drilling that comes later. To drill to final depth below the intermediate casing, the rig owner selects a bit whose diameter is small enough to fit inside the intermediate casing. Additional intermediate casing string are run depending on wellbore design. Sometimes well owners run liners into the well. A liner is a shortened string of casing used to case the smaller open hole section below an existing casing string in the hole. It's just like casing, except a liner does not run all the way to the surface. Instead, the Frank's casing crew hangs it from the bottom of a previously run casing or liner string, using a special piece of equipment called a liner hanger. In this case, there is an intermediate liner and a production liner. Using liners saves money since they do not extend to the surface. Here's an overview of casing cemented into a well. Called primary cementing, the cement's main jobs are to completely isolate or totally seal off all of the oil, gas, and water zones from the wellbore, and to bond the casing firmly to the wall of the hole. Here, the crew has drilled the well to the casing point, the depth at which they will set and cement casing. The driller circulates drilling mud to clean the hole and to make sure the mud is in good condition. Then the crew pulls the string out of the hole. This part of the hole penetrates the producing zone. When cemented in place, production casing seals off the producing zone and readies it for production. Production casing also houses and protects the tubing and other equipment used to produce the well. The operator usually perforates or puts holes in the casing when the well is completed or ready for work to begin. Well completion is the term describing the activities and methods of preparing the well for production of oil and gas. Oil and gas flow into the well through the perforations.
So that's all. I hope you get benefit of this video. Okay. The last thing that we'll speak today about it is completion. We start completion with well casing, then we will continue completion about some other area like no more details. Actually, the completion is a methodology and technology required to produce recoverable reservoir to the surface. So you are doing a drilling, but how you ensure that there is this reservoir, the product that comes from the reservoir is will be safe to flow out from the out to the surface. You are using something methodology, and this all in the well completion. So it's mainly design, selection, installation of the tubular, the tools, the equipment, which is located on the well bore for the purpose of conveying, pumping, controlling production or injection of fluids. This is all completion. So this is completion. This is, you are now here in this zone. You are drilling is stopped. You are drilled. The drilling cycle is stopped. So the completion is to complete the next step after drilling. You are put the POP, which is blowout preventer. You are using the tubing, the annular, the packer. You are put all of these things to start the production. This is called completion. Here, another photo of completion by putting the tubing and the packer. This is the packer. If you remember that I mentioned this one in one slide, the packer. This packer here is to prevent the flow that's coming out from this area, because the flow it should come only in this tubing. Let's have a annotation marker here. Okay, this flow, the flow will come out from this opening here and there, then it will go through this tubing here, there, right? But what prevents the flow that it comes through this area between the tube and the casing? The backer. The backer will stop the flow from flowing in this area. So it will direct the flow to flow only in the tube. So why I need the flow to flow only in the tube? Because I need the tube to be protected here. We have a blowout protection at the top of the wellhead to protect the high pressure of the flow. I have to control it. So to control the flow, it should be through the pipe. So to avoid any leakage comes between the pipe and the casing, we need to put the backer here. This is another also completion design criteria. You need to start with the well bore reservoir interface, then you have producing zones, then you will have the production method, then you have the number of tubing strings. This is like a steps of completion design, how to design the completion. This is also another photo of the tubing or annulars for the drill pipe that comes in different phase. It can also be vertical, as you can see. It can be vertical, horizontal, as you can see. So you can drill horizontally. You can also drill on an angle like this. So you can have also a drilling in an angle, horizontally, 90 degree, or vertical like this. Actually, the completion, it costs money, definitely. It's require money. It's mainly required up to $5.6 million. So it is really a huge cost for completion, because the completion, it consists a lot of things. It consists of the completion linear and tubing. You have a wellhead equipment, including the control system and blowout prevention system. You have the completion fluids, which is the mud, which we explained. This is also money cost. We have completion and perforating crews. We have the crews there that are workers. We have a pumping equipment. This is for the pumping to circulate the system, circulate the mud inside the system. This all also money, so it costs a lot, the completion. So the completion equipment, as I told, we have either subsurface equipment and we have surface equipment. The subsurface equipment includes a tubing string, the nibbles, the mandrels, the packer. This is all called subsurface equipment. Which is the surface? The surface includes the wellhead itself, which is on the surface. the Christmas tree, the flow line, the control and protection system, which is blowout prevention system. So it will be on the surface, on the land, on the platform, on the drill floor. But which will be underneath the surface, subsurface, you have the strings, the nibbles, the backer, the other things. So that's all my lecture today, dear brothers. I hope you get benefit from it and you have enjoyed the lecture so far. Next time we'll explain more details about the wellhead itself, and we'll explain more details about the type of lifting and how it works and how the wellhead actually itself consists of, and what is the Christmas tree in details, what is the valves. This will be in the next session, inshallah ta'ala. So let me know if you have any questions so far before we close our session today.